Let's learn the evolution of AI throughout the last 80 years. If we look at 1940 through 1980, you can tell that in World War II, Alan Turing was able to come up with not only a key to encrypting and decrypting messages for the German forces we opposed, but also came up with something called the Turing test. What the Turing test is it's a way of having a conversation that's undetectable by a human with a robot. In 1950, one of the most famous science fiction authors of all time, Isaac Asimov, came up with the law of robotics. And the law of robotics first says that a robot may not harm humanity or by inaction allow humanity to come to harm. A robot may not injure a human being or through inaction allow a human being to come to harm. A robot must obey the orders of a human being except for when those orders conflict with one of the other laws. And also a robot must protect its own existence as long as it doesn't conflict with the first or second law. So these laws have really, even though they came from a science fiction author, have been pervasive in the thought process of the current evolutions of AI. In 1963, DARPA started to fund AI at MIT and also came up with some of the initial designs for autonomous vehicles. In 1965, Moore's Law was really publicly talked about, and that's where every 18 months or so, CPU processing power was able to double. And then in 1980, this rise of expert systems came about, and expert systems were really about designing rules that could replace some of the human logic. From 1980 to present, we've been able to look at, let's say, in 86, the Nav Lab, which is the first autonomous vehicle from Carnegie Mellon. And then in 1997, Deep Blue was able to beat Garry Kasparov, the top chess player in the world at the time. And really, this is a breakthrough that showed that for the first time, intelligence could actually beat human intelligence. In 2002, the Roomba was first widely announced, and this is an autonomous vacuum cleaner. So this starts to show these, autonomous robots are able to do some of the same functions that a human can do, and potentially even better. And then in 2006, AWS launched cloud computing. And really, this is a big breakthrough as well because it allows some trends that we're going to talk about later that will enable AI to continue to advance. And then in 2015, DeepMind was able to beat one of the top Go champions in the world. So really, these are the key events that have set up the stage for AI in the way that we currently know it. Some of these key trends that we've discussed are that cloud computing itself enables this concept of infinite compute, infinite storage, and then also these AI development platforms. So what this means is that deep learning and machine learning, for example, those are all rising on the tide of the cloud. And then big data, which is one of the key ingredients for deep learning, is something that is available via cloud computing. And then also big compute. So if you have this concept of infinite compute, where is it coming from? Where it's coming from cloud-based systems, CPUs, GPUs, ASICs, which are specialized AI chips. All those together are really the raw ingredients for AI. And so if the cloud didn't exist, we wouldn't be at the place that we're at in terms of AI development. So as you can see, there's some key trends that really enable AI. And cloud computing is really the facilitator of all those key trends. It's infinite compute, infinite storage, and also these AI development platforms. These are all the raw ingredients that enable the trend of AI as we currently know it.